Okay, class. I don't know why this uh, recording device was acting up, as you can tell from the beginning of the video. It wouldn't bring up my document camera. It's been doing that at least last couple of weeks. I'm not sure why, but anyhow. So I want to do two different recordings. One is for section 8.1 and one is for section 10.2, and then that will be those will be the last two recordings, and that's to cover the quiz 3 material that's coming up. And so this is a study guide for your quiz 3, which you can find and print from your quiz 3 module in your math 1342 statistics Canvas course. And remember what happens with quizzes. With quizzes, we've had we're going to have a total of 3 quizzes and 3 tests. So remember what happens with quizzes. You prepare a study guide. So you decorate this, and I know there's not much room to decorate in the front, but you can certainly decorate in the back. And you should put at least find one example of each in your homework when you do your online homework to go back and put in here, or you can use an example from our notes or our ebook and put that, on the back here. And you can use that while you take your time quiz. So quiz 3 is timed in Connect Math. And the prereqs are you have to finish the homeworks with 60% mastery. So that would be 7.1, which is margin of error, 7.2, confidence intervals for the mean when sigma is known, Section 8.1, steps in hypothesis testing, traditional method, and Section 10.2, determination of regression line equation. Okay, and so this gives you an idea of what you're going to need to be able to do for the quiz. And so this first part, this has to do with multiple regression. So I'll cover that in the 10.2 lesson. But we already covered, let's see, let's start right here is where, yeah, something after multiple regression. This is an 8.1, okay? So this part is 10.2, regression. Be able to determine whether regression analysis should be done. So that's 10.2. So if it can be done, then they're going to want you to express the equation and make a prediction. And of course, if it can't be done, then you just stop. If it cannot be done, if the R is not significant, the correlation coefficient is not significant, then there's no need to provide an equation. And there's for a best fit, lying a best fit, and there's no need to make a prediction then. And of course, on the quiz, you don't know, the system generates 2 problems from it. So you don't know if you're going to get 2 that require regression or 2 that don't require, or hopefully the ideal combo is 1 of each, but you just don't know because the computer generates that, but you'll have 2 problems on your quiz. Then you want to be able to, this is section 8.1, which we're going to go over. For giving conjecture, write down, be able to state the null and the alternative hypothesis. So on these, on your quiz template, there's a quiz template that you should print. And on there, I ask you to write down the conjectures that the computer randomly assigns to you. So write down those problems, those descriptions, and then reveal the null and alternative hypothesis. And then this is section 7.1. Be able to determine the margin of error for the confidence interval for the given parameters. I think 7.1 was short. You only had about 4 problems. So you will have 1 from that section. And then this, this is the critical values for a certain percentage of confidence interval given. So this you did this in 7.2, and we're gonna also do that a little bit again, also in 8.1. So this, we've done some of this in section 7.2, and then also in section 8.1. We'll see some of that again. finding the critical values for the percentage confidence interval given. And in this, these are confidence intervals. So that was section 7.2. So you'll be asked to find confidence intervals. And then this is another problem related to confidence interval. Yeah, so these are both related to confidence intervals. So again, that's also section 7.2 related to confidence intervals. And then this is also section 7.2, but that has to do with sample size, minimal sample size needed. Okay, and then on the computer, you don't know on this one, are you going to get, is variation going to be given to you? Because if it is in the formula, you want to use the square root of the variance. But if standard deviation is given to you, then you want to just use that standard deviation in your formula. And remember, the formula is quantity squared. It's units squared, quantity squared for that. Okay. All right, so that will be for your quiz then. Now in Connect Math, which is time, so you don't need Respondus Monitor for that, but you have to have your homeworks done with 60% or higher. So we'll use the initial get to get in, and as long as your homework is 60 or higher, right, then it will take you to the next level, which is to take the quiz on the computer. Okay. All right. Okay. And then to take the final, what I'll do is a prerequisite to take the final is you have to have taken quiz 3. So I'll also put the password like I do in Connect Math for because your final exam is needing Respondus with lockdown browser and webcam camera, and that's going to be in Canvas. You also have like a template, and you can also use the final exam review guide while you're taking the final. And when you upload that for the final exam review guide, that's worth 5 points extra on your final exam. Now the template is required. This is required. If you don't, there's no bonus points involved on the quiz for this, but if you don't do it, I will take off 10 points for not demonstrating that you studied for the quiz. So this is a requirement per the Concourse syllabus. But for your final, if you complete the final exam study guide, you upload that before you take the final, and that can be used when you take the final. It can be used, and it's worth 5 points bonus. Okay. Okay, so let's see where we're with that. So 8.1's got a lot of vocabulary, so you are going to want to read. We're always asking you to read your ebook, but this is one where you really want to read your ebook, because some of your homework questions, I believe, are like essay type. Well, it requires the reading of the textbook for that. So here it says steps in hypothesis testing, traditional method. So we have a statistical hypothesis is an assumption about a population parameter. This assumption may or may not be true. The null hypothesis, symbolized by H sub 0, is a statistical hypothesis that states that there is no difference between a parameter and a specific value, or that there is no difference between two parameters. Okay, so with the example of parameters, let me just put up here examples of parameters. So that could be when we're finding the means, a mean, and they use mu, the Greek letter mu, or you could be finding a proportion, And they use the Greek letter rho, which kind of looks like a P, right? Kind of like that. It's rho. Or another parameter would be the standard deviation. And that uses sigma. Okay, so those are examples of different parameters. So mostly what we're going to be using most of the time is mean, but just recognize they could easily use rho or sigma. So on this sheet here, this is also going to be important for quiz 3 and also for the final. We're going to be working with this table here initially, and then we'll be transforming our answers into this in the end. But we need vocabulary. So this vocabulary here is still going to be helpful, but just for the symbols, the inequality symbols. And then most of the time we will find our vocabulary up here most of the time where we need the inequality symbol or the equality symbol, okay, for that. So here in this example, these all have mu. These are all means, but they could have just as easily have had all rows or all sigmas. But we just use means, mu, as examples. But any of these this is a parameter, okay? And it says when testing the null hypothesis, the assumption is that the mean, proportion, or standard deviation is equal to a given specific value. When conducting a study, the researcher is looking for evidence to support a claim that's stated as the alternative hypothesis, okay? And then examples of null hypothesis. So I'm just making this up. If I were going to use mean, I could put h sub 0 for sure, not h sub 1 because it's a null. So h sub 0, and I could put like mu is I could put equal to 50 if I wanted to, okay? Or I could put h sub 0. If I didn't want to use mu, I could use proportion, and I could say maybe like less than 38. Or I could use sigma if I'm talking about standard deviation, and I could use greater than or equal to 38, for example. Okay, so those are just examples of null because I'm using h sub 0, not h sub 1, and because I'm using like inequalities, right? Great, less than, greater, equal to, or even the equals. The alternative hypothesis symbolized by h sub 1, and formally, it used to be h sub a for the alternative, but they recently changed that from h sub a to h sub 1. But it used to be, you know, h sub a for the alternative until they changed that up about 5 years ago or so, 10 years ago. But this is a statistical hypothesis that states the existence of a difference between a parameter and a specific value, or states that there is a difference between two parameters. So an example of an alternative could be something like h sub 1, and I could say mu is not equal to 50, and that would be not equal to. I couldn't put equal because if you look on the bottom of h sub 1, see your choices down here. Even if you look up here, see your choices for h sub 1. You see you are limited. So I couldn't say this was mu equal to 50. That wouldn't work. So I could say h sub 1, and if I want to do a proportion, I could say greater than a number. So I could say greater than, if I wanted to say greater than 38, for example, I could. And let's see. And I could say H sub 1. I could say less than. So I could say sigma for standard deviation less than, I could say, just make up a number. I could say 85, just making this up. Okay, let me check that out. So using less than, so you see there's a less than there for H sub 1, even over here. Greater than, so yeah, there's a greater than there, even over here. And then not equal to. So yeah, there's a not equal to there. And I think I need to check the top because on the null, let me see, I have equal. So you see that's an example there. But I think I actually have to change this and see how I have P is less than 38. That actually wouldn't work because if you look at the null, your choices are either up here equals, right? Or H sub 0, if you go this route, it's less than or equal to or greater than equal to. So actually, this one wouldn't work then. I couldn't make that a null based on what I see on the chart. I could do less than or actually less than or equal to. And then same thing here. Well, actually this one's okay. Greater than or equal to 38. See this right here? Okay. So just as an example, okay. So what happened was initially it was set up as one of these three cases. When you set up the conjectures as two-tailed, right-tail, or left-tail, it was set up as one of these three examples. And then just recently, they've recently changed this, some 5 or 10 years ago, they've changed it now to where they would prefer the systems now to, if it's this for two-tail, well, the two-tails stay the same, see? But the right tail didn't. See, the right tail changed where they just made this equals. And same thing on the left tail change where they just made this equals, see? But the H sub 1s are the same, but they still got a little edit for that little facelift, okay? Okay, so I'm gonna let you, I'm not gonna read through all these pages. I'm gonna let you read through these, but I am gonna highlight. Let me just see what I'm gonna highlight. I'm gonna highlight because in the reading, and in your questions, there are some questions that were highlighted based on the reading. So that I do want to highlight. And that would be, let me just make sure. Yeah, so here I have H sub A, formerly H sub 1, formerly H sub A alternative was used. So formerly H of A for the alternative, it was used. So they used to use H sub 8, but now they're going to start using H sub 1. So I do have a note there. Okay, so read through the other materials, and then what I have highlighted is starting on the page 171, where it talks about the definitions for one type error and two type error. So I believe on your homework, they ask you more information about the type 2 error that occurs if one does not reject the null hypothesis when it is false. The type 1 error occurs if one rejects the null hypothesis when it's true. Okay, so they're going to ask you something related to that. Okay, you can study the squares and they're helpful to look at those. Okay, the other thing I'm going to circle, let's see on this next page, let me see. And I think I have a reference page here of, I have a reference page, I think of 168. I think that's in your ebook. So you might want to check that out. Maybe that's where I'm getting that from. So I have a copy of the ebook. Sometimes I do have a copy of it right up. Thought I had a copy of the of 8.1, but I know I have a copy of 10.2. I guess not. Okay. Okay. Other things highlighted. Let's see. I do see my 8.1. Let's see. Let me see 168 matches with that. Nope, I don't think 168 matches with that. Because I see like 400 and something. Yeah, so let me take this off. I don't think that's a reference to the ebook. Yeah, this ebook, it's like 410 or so. So yeah, so okay. So, but still I have that highlighted. Okay, then I have on page 172, nothing on that one. Okay, but here I have the critical regions highlighted. The critical region or rejection region is the range of values of the test values that indicates that there is a significant difference, that the null hypothesis should be rejected. That's on page 173. So I have the critical region highlighted. The non-critical region is a range of values of the test values that indicates that the difference was probably due to just chance, that the null hypothesis should not be rejected. Okay, then I have this highlighted, that the critical value CV separates the critical region from the non-critical region. And I do have a reference here to page 412. I'm gonna write this down. And I do have a reference that that's the ebook. And this has to do with your vocabulary. And so it says that a one-tailed test indicates that the H sub 0, the null, should be rejected. Well, excuse me, when the test value is the critical region. On one side of the bead. It is either a right-tailed test or a left-tailed test. And this is depending on the direction of the inequality of the HA. Okay. And then I have from the ebook on page 413, it says that for a two-tailed test, it says H sub 0 should be rejected when the test value is in either of the two critical regions. So like I said, lots of vocabulary, okay, for this section. And I was going to add for the right tail test, I have the little inequality going in this direction. And for the left tail test, I have an inequality going in that direction. So I have this, I also have this underline. I don't know if that's going to help with your vocabulary. And remember H sub O, remember H sub O is, remember that's the null hypothesis. Whereas on the first one, I have underline, let's see. I have the null hypothesis underlined as H sub 0, so null hypothesis should be rejected when the test value is in the critical region. I have this underline on one side, so that might be important for you. Okay, now let's see. Before I get into some calculations, because I think the next page is calculations. Let me see. Yeah, so we did some of these calculations in section, I think it was 7.1, but it was always a right tail. Now what's going to happen, see, and it's also a little present a little bit different. See alpha and it's right tail. See, this was left tail, and this one's two tailed. Okay, so we've done some of this before, except that now you've got not just right tail, you also have left tail and two tail. So, but before I do those calculations, I did see that my ebook, I have a copy of my ebook here. So in the ebook, I have some things highlighted here, like state the particular hypothesis under hypothesis testing. We talked about the parameters. It could be mean, proportion, or standard deviations. Here I have more examples. I've talked about those examples. And I say it uses the H, so uses the equal sign. That's because, see, we'll start it off here, but when we record our answers, it's going to be one of these that we record. And this is, all of these, see, have equals for H sub 0. And that's what I'm referring to here. And then this one you may use for the alternative less than, greater than, or not equal to. So that's what we're talking about, those symbols there. And then on this page, but this is from your ebook. I just, this is right tail, this, points towards the right, the inequality. This is left tail, the inequality points to the left. These are like, it's kind of like it's what opposite or was contrapositive, right? Like the opposite of less than or equal to is greater than. So you could say the opposite or the contrapositive of greater than or equal to is less than. Like the opposite or contrapositive of equal is not equal to. So that's kind of how that works out. And in this vocabulary, I have most of that vocabulary already. I think I covered all of them here. And then also this vocabulary will be helpful sometimes also for the inequalities if you don't see them here. So those are both going to be helpful. But there's more vocabulary that should be similar to what you see. Okay, so nothing highlighted here, but there's some bold vocabulary. Here, this looks like from your workbook, right? So if you take a look at that, let me see what your workbook had. I thought I saw the squares in your workbook. Yeah, so it's saying that this is a type 1 error and type 2 error. So it's similar. And then I have this highlighted, like I had you highlight the type 1 and type 2 error in the workbook. And then I do have this, if you want to write this down, looks like I do have extra information here. Let's see. Let's see, example for the type 1 error occurs if you reject the null hypothesis when it's true, convict, rejecting the null hypothesis of innocence, a criminal, a defendant when the defendant is actually innocent, the null hypothesis is true. The type 2 error if you do not reject the null hypothesis when it is false. Example, failing to reject the null hypothesis of the innocence. So fail to convict the criminal defendant when the defendant is actually guilty. The null hypothesis H sub 0 is false. So like people who have to go to law school, they would have to do some of this logic, some of this hypothesis testing in their studies, then to do some of them, cover that. Let's see. I say in hypothesis testing, nothing is being proved true or false based on information in our sample. We're stating there is not enough evidence to say that a claim is probably true or false. The entire population cannot be used. So the only way to prove anything statistically is to use the entire population, which in most cases is not possible. So the decision's made on the basis of probabilities. That is, when there is a large difference between the mean obtained from the sample and the hypothesized mean, the null hypothesis is probably not true. The question is how large a difference necessary to reject the null hypothesis. Okay, and here's the level of significance used. Okay, so yeah, so just read through that. It's a lot of reading, lots of vocabulary. Here, I think I had you highlight this from the workbook, right? Critical and non-critical regions, one-tailed test. So yeah, we had that. Some of this we had, some of this is in the workbook. I don't think all of it is. Two-tailed tests. And then make use of the inequality chart when working problems 13 and 14. Okay. Here's another little inequality chart, but that should be reflective of what we have here. Okay. And then here are your problems. So these are, these are T2 tail, left tail, right tail, alpha. So we're going to do them, some of those first. And then they want you to write conjectures. Let's see. For each conjecture, state the null and alternative hypothesis. Okay. So we'll show you how to set some of those up. And you're going to have one of these on your quizzes, one of these type on your quizzes, and then on your quiz 3, and then you're going to have 2 of these conjectures on your quiz. So it's a total of 3 from this section. You kind of think through that. Okay, so let's see. So let's see, to show how to calculate these here. Okay, so let's see. Okay, so first of all, find the critical value for alpha equals to 0.01, which is a right tail test. Okay, so this one's going to have a positive answer. Because, and we know that already because it's a right tail test. Okay, and what they've done is they've helped us draw a picture already. What they've done in their calculation is they have 1 minus alpha, which for us it's 1 minus 0.01, because that's what your alpha is right here. And then that gives you 0.99. Okay, and so what we want to do is, and that's see, it's right tail, so that's this value right here. See this right here? So that's this critical region. That's this point. Well, actually 0.01 is this right here, 0.01. And actually this value here, that value is 1 minus 0.01, which is 0.9900. Remember, area underneath the curve is 4 decimal places. So we want to locate the corresponding z-value for area equals 0.9900. So if I use the table instead of the calculator first, if I use a table, most of the time, 90% of the time, most of the time, the table is going to be the same as a calculator, but every now and then we're off a little bit on that. But you want to look for 0.99, basically, right? And it turns out that when you look for that on your table, you want to get your, we want to locate the corresponding value for area, and you want to use your standard normal, and it's cumulative, right? It's called your cumulative standard normal table. So you can get your tables out. I think it was called E, right? In your workbook. Okay, so I'm gonna look for 0.99, and you see here, this looks like it's on the positive side. See, so if I look on the positive side, and I'm looking for 0.99. So there's 0.5, 0.8, 0.99. Okay. Wouldn't it look like it would be between these two? 0.99 would probably be between 0.9901 and 0.9898. So if I use my rulers, I want to use my rulers. It looks like I'm looking at the 2.3. And then if I yes, it looks like it's between these two. So 0.02 and 0.03. Okay. So when I write that down, I'm going to write 2.3 and I said 0.02 and I said 0.03. So this area is 0.9898 and then this one was 0.9901. Okay. And when I double check, well, I got to find it. I got to see which one's closest to. So remember this formula, area minus potential. That was back from test 3. So area is 0.99 and you're going to do that twice for both of these. So one of them is 0.9898. The other one's 0.9901. And I'll get the calculator. Remember, this calculator is easier to use for the subtraction as opposed to the graphing one because of the scientific notation. It just saves a little bit of time. 0.99 minus 0.9898. So use our basic calculator. That's the absolute value of 0.0002, which is just 0.0002. The other one, 0.99 minus 0.9901. The absolute value of negative 0.0001, which is 0.0001. So when you look to see which one is smaller, you look at both of these because the other ones are tied. One's place, tens, hundreds, thousands. So these are tens, hundred thousands, 10,000s. This one's smaller. This one's smaller distance as opposed to that. So when you backtrack, you're going to backtrack to the 0.9901. You're going to backtrack to the going to backtrack to this. Okay. So that means you want to go with the 2.33. Remember, it's going to be positive. It's going to be positive. And let me see if I look at the exercises. Let me go back to exercises, how they were asking that there. Use a Z table, and they're calling it table E. Yeah. Okay. So we're using the table E. They call it the Z. They call it the Z table is also what they call it. And what we're doing is we're finding the critical values. So the critical value is 2.33 because it's this 2.3 and then 0.03. So it's like you're adding the 2.3 plus the 0.03, which gives you 2.33 is what's happening on that. Okay. And let me see what else. And the Yeah, they don't put a letter in front of it. They just have the numbers. And let me just see something else. Let me see. Because like on this table here, let's see. They were calling it Z sub C also. Z sub C. So they don't really call anything in the, I was looking at the answer key in the book. So 2.33. So I guess it'd be okay to call it Z equals 2.33, or you saw how Z sub C, critical value, related to the critical value. I guess either or would be okay, but I think the computer just wants you to type that in. And then if I do that also using the calculator, most of the time comes out the same, but sometimes last week there was a discrepancy when I was doing that with one of these. In my remote classes, there's a little bit of a discrepancy, just off by like a hundredth of a digit. But here, mu would be 0 and sigma would be 1. And so here, if you use second vars, and number 3, inverse norm. Okay, so area, and you want, this is always reflective of area to the left of the curve. When the calculator does this, it's already thinking of area to left of the curve. So you want this area here, which is the 0.9900. So that's why I would put that as 0.99. 0.9901. 2.32634787. And I round to nearest hundreds. Look at the rise at 5 or more. Yep, it's a 6, so add 1 to that. So we're looking at 2.33. And it's right tail, so we're going to use positive answers for that. Okay. Okay. All right. Now on the next page, there's a couple more examples. Now, if you have left tail, what happens is you have a negative answer. And there's no need to do any kind of subtraction like 1 minus alpha like we did on the other one. So here you see this number here is already right here. So the calculator is ready to go. And so you're ready to just look up, the corresponding, Z value for that area, which is 0.01. Okay. And so we're looking up the area 0.01. Okay. And we're on the negative side. See, this is on the next. So when I get that table again, that table E, and I'm on the negative side and I'm looking for 0.01. Okay, here's some 0.01s. .01, right? So 0.0102, 104. Yeah, wouldn't it be 0.0100? So wouldn't it be like between these two here? That arrow will fall in between those two as far as size goes, right? So 102, so it's 99, right? And it's growing, 102. Okay. So let's see. So we have 0.02 and 0.03, negative 2.3. Yeah, and these are also negative. If these are negatives, these are negatives. So sometimes on my tables, sometimes I already have little negatives drawn. I just couldn't find my other table, so I got this one from an old workbook that had that. So, but you know, if these are negatives, so are those. So I'm looking at negative 2.3. And then 0.02 and 0.03. All right. Okay. So let's see. So negative 2.3. 0.0102 and 0.0099. And this one was negative 0.02. This one was negative 0.03. Is that okay then? Okay, so then when I do my subtractions, area minus, remember it's area minus potential. So area is 0.01 minus both of these. So this one's 0.0102. This one's 0.0099. And then if I just use a basic calculator, I won't have to worry about scientific notation. It'll be a little bit easier. If the only one you have is a graphing calculator, then you will have to change your scientific notation. So this is negative 0.0002, which is 0.0002. 0.01, take away 0.0099. 0.0001, which is just 0.0001. Okay. And let's see. And I just, yeah, even though we use different numbers from the other problem, we still ended up with, they're just coincidence. We ended up with, it looks like the same value, see, as the other problem. That's just coincidence, but you see we use different numbers. So it's just coincidence how we got the same thing there. But when I look to see which one's smaller, again, they're all the same ones place, tens, hundreds, thousands. It's not till you get to the 10,000s, you get a 1 and a 2, and the 1 is smaller distance. This is a smaller distance as opposed to the 2. So when you backtrack to this, and then you backtrack to this, and you backtrack to this. Okay. And you do want to use a negative answer. So we're going to how do I word it over here? Let me see. So we're using table E, and I'm going to just say the critical value is 2.33, and it is going to be, oh, it's going to be positive. It's going to be positive. I know we're looking at it on the negative side, but remember it oh wait, it has a negative answer. Has a negative answer. Okay, so it should be negative. It should be negative. Yeah. Yes. So it should, and we do see it there. We do see it there, but also we see it there, and then also it tells you that it's supposed to be negative. So yeah. Okay. Now, again, if we use the calculator, we're doing second bars, number 3, inverse norm, and area is equal to area. It's, remember, it's to the left of the curve. So remember, it's 0.01, mu is 0, sigma is 1. So we use on the calculator second vars, and then number 3, and then the area is 0.01, mu is 0, sigma is 1. And that gives us this. So it's negative 2.32. And then you look at the number to the right. Is that 5 or more? Yeah, that's a 6. So you're going to add 1 to it. So it's negative 2.33. Of course, there's more digits back there, but we're rounding to there's hundreds. So yeah, we get that. So you see. Okay. Okay, then the last example down here is what if you have a two-tailed test? Well, the two-tailed tests, these have plus or minus answers. So you have to remember to put the plus or minus if you're ever working with a two-tailed test, okay? And I can show you this in the multiple regression lesson. The last thing I'm going to do, I'm going to show you this table. These are the tables, extra sheets I ask you to print. You see two-tailed tests. See how all these have plus or minuses? And you see how the right-tailed tests, they're all positives. And you see how the left-tailed tests, see how they're all negatives. So that's the standard for that, okay? All right, okay. So here, what would happen is you would use alpha divided by 2. So alpha is 0.01, and you would divide that by 2. So when you divide that by 2, I'm just going to use this calculator. 0.01 divided by 2 is 0.005. And you see, that's why they have, that's why they have these here on your paper, okay? And then what we're going to do is we're going to look up the corresponding z-value for area equal to 0.005. Okay, because we want to look up area to the left of the curve, and so you see that would be okay. See, that's there. So then when you set this up, 0.005. So it's going to be, you're going to look on the negative side because it's to the left of 0. It's negative. And you're looking for 0.005. 0.005. So wouldn't it be between these two here? Let's see. So you see that 2.5, negative 2.5, 0.005. It wouldn't be between these two right here. So we're looking at these two numbers right here, negative 0.07 and negative 0.08. So 0.005 would be between these two, somewhere in there, okay? Okay, so when I write those down, negative 2.5, and then 0.0051 and 0.0049. And then we have negative 0.07, negative 0.08. Okay. Okay, so then, okay, so now when I do the distance, area minus potential, I want to see which one's shorter. Or the other case, which I think is going to happen here, is, remember, there's two things that can happen. Either one's shorter than the other, or they're tied. And if this is the one where they're tied, then we're going to have to take the average of both z's. So here the area is 0.005 minus these potentials, 0.0051 and 0.005 minus 0.0049. Okay, so when I do that on my calculator, 0.005 minus 0.0051, that's the absolute value of negative 0.0001, which is just 0.0001. 0.005 minus 0.0049 is 0.0001. Okay, and then you want to find the shortest distance. Oh, and then see how they're tied? These are tied. See how these are identical? And so what happens is, since, let me write this over here. Since these distances are tied, right? They're both 0.0001, right? So they're tied. Then what you want to do is you want to take the average of both your z values. And so when we do that, open parentheses, I have negative 2.57 plus negative 2.58, and then I'm going to divide that by 2. Okay, so I'm going to use my calculator. Parentheses, negative 2.57 plus negative 2.58, and then divided by 2. It's negative 2.575. And when you round that to nearest hundreds, is that 5 or more? Yeah, so add 1. So that's about negative 2.58. And oh, and then also, actually, remember, it's two-tailed. This is two-tailed. Because they said it was two-tailed, we have to have plus or minuses. So actually, we're going to have to say that the critical value is plus and minus 2.58. Plus and minus 2.58. And that's because it's two-tailed. And I don't have much room to do the calculator version, but if I do the calculator version, so like where can I squeeze that? It would be the second vars and then number 3 inverse norm, and then your area would be to the left of the curve 0.005. Mu is always 0 and sigma is 1. So when we do that second vars number 3 0.005, that'll be negative 2.5758 and a whole bunch of other numbers, right? But we went around to there's 100. So that's 7. Look at the number to the right. Is that 5 or more? And what was that number? 257. That's a 5. That doesn't look like a 5. So yeah, it's 5 or more. So then add 1 to that. So you have 2.58. Yeah, so it does come out the same. And then you just still want to use, the plus or minus because it did say it was two-tailed. So you still have to remember to do the two-tailed on that, okay? Okay, so on the next page, procedure for table finding critical values for specific values. Okay, I guess I think you can, I guess, look at that for extra reference, but I've done these. I've shown you on the calculator and how to do those, so I think we'll be okay. And I'm not going to do, they have more examples like A, B, and C, but I'm not going to do those extras. So explain the ones that were there. Okay, so, but I think that would cover that though. Okay, now there's a conjecture. See, they don't have the conjectures in here. So state the hypothesis, identify the claim on the last page. Let's see. Yeah, so let's talk about this. Extra examples. This part, state the hypothesis, identify the claim, find the critical values from appropriate table using TI-84. So that's what we're doing right now. Those are the two things covered in 8.2. Okay, so we're not really going to be doing this part here. The last thing when I show you the multiple regression, we'll do 2 problems where we'll kind of do these things here. But for now on the quiz, they just have you do the conjectures. But let's see. Let's see. Okay, now okay, I had asked you to print some extra problems because you see that we have to show you how to do the conjectures, and those were really not in the workbook, so I had to have you print. Like if you didn't print them, you can look at your ebook because that's where I'm getting these from. These are coming from your ebook. So I showed you how to do these a while ago. See, I did both the table and the calculator. Usually the table is usually more accurate, I think, than the calculator. And sometimes it's plus or minus. If it's two-tailed, if it's negative, it's because it's left tail, and if it's right tail, it's positive. So first when we started this, it was all right tail, and now they brought these in, okay? And now I'm going to show you how to do this part here, the conjectures where you keep track. Now the computer won't want you to keep track of the claim, but if you're going to do hypothesis testing on problems, you should keep track of the claim, but the computer doesn't test you on that. But I will do it in my examples. So see the ones that are circled, but usually the ones that are circled are the ones that I usually do with my students here. So I do 1, 2, 3, 4. I do about 5 problems with them. And then there's extras in your ebook. And then see these little results here, those are the answers. If you want to practice on your own, you can practice on your own and then check your work. But I'll do the ones that are circled. And then this was a good one too that I added into your ebook. Okay, so now let me get some extra paper out. Okay, so we start with 13, and you're going to need this table. And when we set up these conjectures, I'm going to first try and set it up as one of these 6 items, right? 1, 2, 3, 4, 5, 6. But when I record my final answer, this is what the Connect Math wants. Okay. And it used to just be this, and we would stop. Like 10 years ago, we stopped. But they've since, like, if you look at antiquated journals, they would use this. And I think these make more sense. And the book, your ebook has, I saw a little paragraph and their reasoning as to why they kind of changed that. Most statisticians, I think they don't like how they've changed that, because I think this makes more sense, but they have a reason why they changed that. And most of the computer programs are also honoring that and doing that. Some of them aren't. Some of the homework, some of, like maybe Pearson, some of the other products, they don't. They just recognize that sometimes, but they're starting to change to these. And your Connect Math has updated. Does your system does do these? Okay, so if I look at the problem 13C, and we need the vocabulary. We also need our vocabulary. Usually it's this. Sometimes if you don't see your vocabulary here, then we will actually use this from chapter 5 just to grab the inequality though, okay? Okay, so if you look at 13A, it says, for each conjecture, state the null and the alternative hypothesis. So on your quiz, when you print your quiz template, you're going to see that I want you to write down the conjecture that's given to you. Computer's going to randomly give you a little phrase there, or I guess it's a sentence or a little phrase. So everybody, you need to write down the one associated that the computer gives you and write that down, because that counts as rubric points. And this one says, the average age of a community college students, the average age of community college students is 24.6 years. So here the vocabulary is 24.6 years. So when I look for that vocabulary for the is, that's actually going to be like, it's actually going to be like this one is, even though I don't have just is there, maybe I should just add that here. It's closest related is equal to, If you look at all the choices, the closest is equal to is, okay? So really I should have an is there for one of them. And that's the equal sign. So then you go to the bottom here and you say, well, go start with this first. And you're like, well, where do I have an equal sign? See right there? That's going to be your claim, your H null. So you would write, you say, oh, okay, that looks like this one, H null mu equal K, H1 mu not equal to K. So then you say, okay, I'm going to write H null mean is the mu equals 24.6. And then H sub 1 would be mu not equal to 24.6. And then actually on this one, this is the only one that stayed the same. This is an example of a two-tailed test. And you see, when you go back and I was getting ready to change it, this is the only one that stayed the same. On these, when they edit them, what happened is they changed the null to equal, see? But the H1 stayed the same. And here, the H sub 0 changed, see, to equal, but the H sub 1 stayed the same, okay? But this is, for us, this is a two-tailed test. Okay, and then this is, you know, what you would put in the computer here when you type that in, okay? That's your setting up your conjectures for, oh, and then you put a star on the claim, and it was the is, which was this. So your claim is actually on the H sub 0, that's your claim. Okay. Okay, so now let's look at 13C. 13C says the average age of attorneys is greater than 25.4 years. Okay, so let me see, let me fold this up. So 13C, and the keyword is this is greater than 25.4 years. And the keywords for is greater than is right here. See this? Is greater than? It's greater than. See that? So it looks like this. Okay, so then you go down again to the bottom and you're looking for that greater than. Oh, see it's right there? And that's where your claim goes. That's where your claim goes. So we start off with, okay, I see that's H sub 0 mu less than or equal to K, H sub 1 mu greater than K. So we want H sub 1 mu greater than 25.4, and we're going to put a star on that. That's our claim. And then we have H sub 0 mu less than or equal to 25.4. Okay. But then we can't stop there. We used to be able to stop there, like some 8 or 10 years ago, we would stop there. But now something new. Now they want us to do this new version now. So this is a right tail test. So now they want us to write it up like this, where you just change now the null to equals, and we will leave this the same. Okay. So now what they want us to write is H sub 0 mu equals 25.4. and H sub 1 mu greater than 25.4. And then this is what they would want us to write. And this would be an example of a right tail test. See how the inequality is pointing to the right? This is a right tail test. And the computer's not going to ask you if it's two-tailed, right-tailed, or left-tailed. It's not. It should. And it's not going to ask you to put the claim. The claim is this. So again, I could put a little star there. That's the claim. It should, because when you do a real full-blown hypothesis testing, you got to keep track of all those things to get your correct answer at the final end. But that's fine. Okay. Okay, now let me do 13F. Okay, so 13F says, let's see. Okay, can you give me a minute? Go ahead and finish reading that and just give me a minute. Let's see. Okay, class, I'm back. So let's see. Did you read 13F? So the average resting pulse rate of a marathon runner, or I think I left out a word. The average resting pulse rate of a marathon, that should be a marathon runner, I believe, is at most 80 beats per minute. So I guess you can put runner here. Okay, so 13F. Okay, so the keyword would be is at most 80 beats PM, right? Per minute, right? And if I look at most, where is at most? So at most, sometimes I have to go here. Sometimes I have to go to the binomial keyword. See at most right there? See that symbol there? Less than or equal to, less than or equal to, less than or equal to. All right. All right. So then now I go to the bottom and I look for that symbol, less than or equal to on the bottom. There it is, right? Less than or equal to, there it is right there. See that? Okay, so, and that's where my star goes on my claim. Okay, so then I have H sub 0 mu less than or equal to K, H sub 1 mu greater than K. And so I'm going to go, my claim goes on H sub 0 mu less than or equal to 80, H sub 1 mu greater than 80. So you see, it's like it's contrapositive, right? So opposite of negative, less than or equal to is greater than, it's a contrapositive. Okay, but then they don't want you to stop there. Now we used to be able to stop there a few years, like 10 years ago. Now they want us to come up, and this is right tail test. They want us to come up here, and they want us to write it like this. And you change the null to equals. So then I'm going to say, okay, so here's my claim. Usually if you just put a star, that means that's your claim. They know that. So H sub 0 mu equals to 80. H sub 1 mu greater than 80. And that one also happens to be another right tail test. Okay. Okay, and then, okay, two more problems. Okay, we're gonna look at 14A and then 14C. Okay, so 14A says the average age of first year medical school students is at least 27. Okay, so that's 14A. Okay, so it said the average age of first year medical school students is at least 27 years. Okay, so there's your keyword, is at least. So if I look at that on my sheet, is at least, to go down here. Let's see, where is that? Is at least. Oh, is it over here? At least. See that? At least. And see that inequality? You want to grab that inequality, greater than or equal to. Okay. All right. So now when I go to the bottom, looking for that, I bet it's over here. Yeah. See that over there? See that? That's a null. So that's where my star goes on that. See? So I have H sub 0 mu greater than or equal to K, H sub 1 mu less than K. So that's where my claim goes. So for us, we have H sub 0, and there's my claim. I have mu greater than or equal to 27. H sub 1 mu less than 27. But now they don't want us to stop there. Now they want you, this happens to be left tail, they want you to come up here And they want you to change the null to equals, and this is left tail. Okay, so now I have still, this is my claim, mu greater, equal, said equal, change that to equal, said equal to 27, and then it's still the null. I mean, still the, it's, yes, the null is still the claim there. Mu, that doesn't change that, but it just changes to an equal. And that's what connect your system, that's what your system wants, okay? Okay, and then the last one we're gonna do is C. And it says the average number of monthly visits or sessions on the internet by a person at home has increased from 36 in 2009. Okay, so this is 14C. Okay, so this one, they actually want this keyword here, increase. At first I got thrown off. Because the has, I did it wrong the first time, and then I checked my answer, and the has threw me off because I went with has changed, but it didn't say change. It says has increased. So I got thrown off by the has, and it's not has changed, it's increased. So even though this doesn't have has in it, it has increased, which is more important. So this one is tied to this. And I didn't see increase here at all down here, but increase is, that's really the only one that has increase right there. And here's the symbol for that. So yeah, so just be careful because I got thrown off by that. And so when I go to this bottom and I look for that symbol, see that right there? That's where my claim goes. This is a right tail test. So I have h sub 0 mu less than or equal to k, h sub 1 mu greater than k, and my claim goes on the alternative right there, which used to be h sub a for alternative. They've changed that to h sub 1 also. Okay, so now we say h sub 1 mean greater than 36, and then h sub 0 mean less than or equal to 36. Okay, but then they don't want you to stop there. Then they want you to go up to the top, and then you just change the null to equals. Okay, so now you have h sub 0 mu equals to 36. H sub 1 mu greater than 36. And this is what they want. And don't forget your claim. Your claim is on that. It's your star. When you put your star, that's your claim. Okay. So on your quiz, you're going to have two problems that they want you to set up. And just remember, I want you to write your conjecture, whatever the little story, whatever the little, like 13C and 14A that we did, whatever the little story is that they give you, write that down. And then in the end, when you put it in the computer, this is like your scratch work, right? Your scratch work. In the end, when you put it in the computer, this is what they want, you know, pretty much in your computer. And you can tell when you do your homework for that. Okay. All right. Okay. So I'm going to take a little break, and then a little bit, I'm going to get ready to do the multiple regression video, and then I'll put those up for you. Okay. So good luck with your homework for that 8.1.